Hello everyone, welcome back to One Engineer. In the previous episode, we explored the Profile toolbar. Today, we'll learn about one of the most important concepts in CATIA's Sketcher, the Constraint Toolbar. Creating geometry is easy, but creating stable geometry requires constraints. Now let's understand what constraints are. Constraints are rules that control the size, position, and relationship of sketch elements in CATIA. We use constraints to prevent unexpected changes, define how geometry behaves, control the size and location of sketches, and eliminate unwanted movement. In simple words, constraints make our sketch accurate, stable, and fully defined, which is very important before creating any 3D feature. Let's understand why constraints matter. An under-constrained sketch can move unexpectedly. This creates unstable geometry. When design changes are introduced, these instabilities can cause feature failures and model errors. That's why professional CAD designers always aim for fully constrained sketches. CATIA provides two main types of constraints. The first is geometrical constraints. The second is dimensional constraints. Geometrical constraints define relationships between entities. Dimensional constraints define actual values, such as distance, radius, diameter, and angle. Let's look at them one by one. Coincidence is one of the most commonly used constraints. It forces two elements to occupy the same location. For example, a line endpoint can be constrained to a circle center or another point. This ensures the entities remain connected. The horizontal constraint forces a line or points to remain horizontal. Even if we modify the sketch later, the geometry will maintain its horizontal orientation. This is useful for creating stable layouts. The vertical constraint works similarly. It forces geometry to remain vertical regardless of future changes. This helps maintain design intent and improves sketch stability. Parallel constraint ensures two lines always remain parallel. If one line changes position or length, perpendicular constraint forces two lines to remain at 90 degrees to each other. Tangency creates a smooth transition between entities. For example, a line and an arc can be made tangent. This eliminates sharp discontinuities and creates smoother geometry. Concentricity ensures that circles or arcs share the same center point. This is commonly used when designing holes, shafts, bearings, and cylindrical components. Distance constraint controls the spacing between sketch elements. Instead of manually positioning geometry, we define an exact distance value. Radius and diameter constraints define the size of circular geometry. These constraints are essential for holes, shafts, bosses, and cylindrical features. Changing the value automatically updates the geometry. Angle constraint controls the angle between sketch elements. This is useful for inclined surfaces, brackets, supports, and many engineering applications. Symmetry constraint controls the symmetry of geometric elements around the reference. We have to select geometries first and then reference, so symmetry option will be enabled in the CATIA. Looks how symmetry is applied here. So in order to make a constraint, we have to select a line and make it horizontal. And then we have to select and give references with the origin, provide some constraints, modify the figures, and we have to check if still that geometry is frozen or some part of it has some degree of motion. So that we have to check. And then whatever degree of motion is still there, we have to control that with some constraints again. So we are modifying it so as it will be fully constrained, and we will be checking at the end the status of it as well, until it becomes fully constrained. In order to make the circle fully constrained, we first have to make the center of the circle fully constrained by giving the required dimensions with respect to the origin. Then, we need to define the diameter of the circle. And that is how we can check whether our circle is fully constrained or not. Let's compare two sketches. The first sketch is under constraint. Some geometry can still move. The second sketch is fully constrained. Every element is completely defined. A fully constrained sketch is more reliable, easier to modify, and preferred in industry. When creating sketches, follow these best practices. Use geometrical constraints first. Apply dimensions only where necessary. Avoid duplicate constraints. Keep sketches simple. Aim for fully constrained geometry whenever possible. Following these practices will help create robust and professional CAD models. In the next episode, we'll explore the Operations toolbar and learn tools such as trim, quick trim, corner, chamfer, and other sketch editing functions. These tools help us modify and refine sketch geometry quickly and efficiently. If you found this video helpful, please like, share, and subscribe to One Engineer. Thank you for watching, and as always, happy designing.